Hi, we're still talking about solving systems of two equations, systems of two linear equations. Up until now, you've been able to find coordinate pairs that are the solutions to the systems. We're going to talk now about what special solutions exist. And we've seen these with other equations that we've done. So the first option is what might happen is there might actually be no solution to your system of equations. Recall that normally when you graph a system of equations, you have a line that goes like this, and then maybe another line that goes like this, and the place where they intersect is the coordinate pair that is the solution. What happens when there's no solution is that actually you have parallel lines. And remember that parallel lines have the same slope. Same slope. So if the two lines in question have the same slope, they're never going to intersect, which means that they will never have a coordinate pair where they intersect. They will never have a solution. So that's what it means to say that they have no solution. For infinite solutions, again, remember, normally we had this situation where we had the pink line, we had the green line, and we had the place where they intersect. What happens when we have infinite solutions is that the two equations that we're given are actually the same line. So we might have that pink line, but then if we graphed our second equation, we would find out that, oh my gosh, it's the same as the pink line, which means that every single coordinate pair, like this dot and this dot, you can't see those, this dot and this dot and this point and this point and this point, all of those points, every single point is shared between the two equations. So in that case, you have infinite solutions. So let's now take a look at what these things look like in context. So let's start on the left here. We have two equations, a system of equations. The first is in standard form, and the second is in slope-intercept. So in order to solve these, I'm going to choose to use substitution because I don't have to rearrange anything. So this value is going to be substituted in for y. So x minus 2 times 1/2 x plus 2 equals -4. I'm going to multiply this out. I get x minus x plus, minus 4 equals -4. What happens to my x's is they cancel out because x minus x is 0 x's. And I get -4 equals -4. So this here, when I get this result, that's an indication that I have a true statement, which means that I would actually have infinite solutions. So I don't need to continue solving it because there's no more variables. This statement is true, so I would conclude infinite solutions. And I have to write infinite solutions. Okay, let's look at this one. I have, again, a standard form equation and then a slope-intercept form equation. So I'm going to use substitution. I'm going to take this expression and substitute it in for y. So I get 3x minus 4 times 3/4 x minus 3 equals 12. 3x, and I distribute the 4. The 4s would cancel out here. So we would just get -3x, and then -4 times -3 is positive 12, which equals 12. What happens to 3x minus 3x? That equals 0 x's, so I just get 12 equals 12. That is a true statement. 12 does in fact equal 12, so I would conclude infinite solutions. Great. Let's try this example. So in this example, we have 9x minus 5y equals 12, and 9x minus 5y equals 8. If you use a little bit of common sense, you should be able to figure out that this is going to be no solution, because how do two identical things, 9x minus 5y and 9x minus 5y, how do those equal two different values? But in case you don't notice that, we can use elimination, because it's already set up for that. Instead, I'm going to subtract every term. When I do that, I get 9x minus 9x, which is 0. I get negative 5y minus a negative 5y, or plus 5y, so that's 0. And that is equal to 4. But 0 does not equal 4. This is a false statement. Therefore, we can conclude that there are no solutions. If you're unsure about this, we can also check quickly to see if they have the same slope. And recall that when it's in standard form, you can find slope by doing negative a over b. So that would be negative 9 over negative 5. And here, if we did negative a over b, we would also have negative 9 over negative 5. Those are the same slope. Things that have the same slope are never going to intersect. Take a second, pause the video, and try the last example on your own. All right, if you completed this problem, hopefully you found that you got 0 equals 0. That's true. Therefore, we have infinite solutions. These lines are actually the same line, so they'd be lying on top of each other. So that means all of the coordinate pairs are the same between both lines, so infinite solutions.